In this video, we are going to learn how to solve exponential equations by matching the base on both of the exponential pieces that we have. If we look at this first equation, we have 5 raised to the power of 9x plus 1 equals 125 raised to the power of x minus 6. Now, right now, the first thing that I see when I look at this is 5 and 125 share a common base, or can be rewritten at least in a common base of 5. The 5 is already there, and I recognize that 125 is 5 raised to the third power. So what I'm going to do is rewrite this so that I can see that. So I got 5 raised to the 9x plus 1 still, that doesn't change, equals, I'm going to rewrite the 125 as 5 to the third, and it still has that exponent of x minus 6. Now at this point, I've got the same base. I just need to do something with the exponents to make sure that we can actually solve this. So I'm going to take this 3 that we just figured out from that exponent and distribute it into the existing exponent. So my new equation here is going to be 5 raised to the 9x plus 1 power equals 5 raised to the 3x minus 18. Now at this point, the bases are exactly the same. All I've done is change the appearance of that 125 to make it a 5 to the third. I didn't change the value at all. I just changed the appearance of it. And now that I have that same base, I can go ahead and ignore the base and try to work with what's left over. So if I look at solving that equation that's left over, the 9x plus 1 is equal to 3x minus 18, I'm going to go ahead and collect the x values on the left side. So I have 6x's if I subtract the 3x. And if I subtract the 1 over to the right side, I get negative 19. And then I can finish this off by dividing off the 6, and I get x equals negative 19 divided by 6. So our first step there was to recognize that 125 is a power of 5. And in doing so, I rewrote that so that the 125 was 5 raised to the third power. We can then distribute that new exponent of 3 to the existing exponent of x minus 6. And once those bases are the same, we dropped them off and solved the linear equation that was left over. Now we can do the same thing looking at the second example, even if one of those fractions or one of the bases is a fraction. Because looking at the bases, we've got a base of 3 on the left side. If I ignore the fraction for a second and just look at the 9, that's also a power of 3. So I'm going to rewrite this as 3 raised to the 4x plus 7. Leave that one alone. But then the right side, I know 1 over 9 is the same thing as 3 raised to the negative second power. So I'm going to rewrite it as that. That's the same value. It just looks different. We changed the visual, but I haven't changed what it's equal to. And then I put that existing exponent of 5x plus 3 where it was. Now I've got the same base of 3. I'm going to take this new exponent of negative 2 and distribute it to the existing exponent. In doing so, I get the new equation of 3 raised to the 4x plus 7 is equal to 3 raised to the negative 10x minus 6, multiplying that negative 2 into that exponent. But at this point, the bases match. I'm going to drop those off and just work with the equation that's left over. I'm going to collect the x's on the left side again by adding 10x. So I get 14x's on that left side. And then I'll subtract the 7 off to the right side and get negative 13. And then I can finish solving for x by dividing off the 14 and get x equals a negative 13 divided by 14. So looking at that second example again, we recognize that 1/9 was a power of 3. So we rewrote it as 3 raised to the negative second power, not changing the value, just changing the appearance. And then we distributed that -2 to the exponent that was already there. Got a new exponent of negative 10x minus 6 on that right side. Once those bases were matched at 3, I could drop the 3's off and set the exponents equal to each other. We added the 10x to the left, subtracted the 7 to the right, and finished by dividing off the 14. So this is one way that we can solve exponential equations, and it works well when we can recognize that the bases can be written as a common base, like we did here. If those bases can't be rewritten as a common base, we would need to use a different way to solve this. But when we can go ahead and use this process.